Momentum refers to the quantity of motion that an object has. Momentum depends upon the variables mass and velocity. In terms of the equation, the momentum of an object is equal to the mass of the object times the velocity of the object. Thus, P equals mv, where m is mass and v is velocity. The equation illustrates that momentum is directly proportional to the object's mass and directly proportional to the object's velocity. The product of force and the time during which it takes is known as impulse. J equals F times delta t. In terms of impulse, Newton's second law can be written in yet another form, in which impulse is equal to the change in momentum.
The impulse-momentum theorem states that an impulse delivered by an object causes the object's momentum to change. An example of it is playing baseball when you hit the ball. When the net force acts on an object, the impulse of this object is equal to the change of the momentum of the object. The conservation of momentum is a fundamental concept of physics, along with the conservation of energy and the conservation of mass. Momentum is defined to be the mass of an object multiplied by the velocity of the object. The conservation of momentum states that, within some problem domain, the amount of momentum remains constant. Momentum is neither created nor destroyed, but only changed to the action of forces as described by Newton's laws of motion. Dealing with momentum is more difficult than dealing with mass and energy, because momentum is a vector quality having both a magnitude and a direction. Momentum is conserved in all three physical directions at the same time. It is even more difficult when dealing with a gas, because forces in one direction can affect the momentum in another direction because of the collisions of many molecules.
So we're going to start with this diagram of two objects collide with one another, and the three types of collisions. First is the elastic collision. The objects bounce perfectly off each other in opposite directions. The inelastic collision, the objects travel in the same direction after the collision. And the perfectly inelastic collision, the objects stick together and travel in the same direction. Elastic collision is when objects collide without permanent deformation and without generating heat. Think of a band of elastic. You can stretch it and pull it all you want, but once you let it go, it returns to its original state and size. The same is true for elastic collisions. The objects come out of the collision unharmed, like they never collided at all. You can see this type of collision when you play a game of pool. Hitting the cue ball sends it across the table into another ball. As it collides with the second ball, it is set into motion. The momentum of the cue ball is transferred to the second ball, but neither ball is permanently deformed. Each ball looks the same as it did before the collision. They just moved to different locations on the table. Objects that collide in an elastic collision transfer momentum if they are traveling in the same direction, but when they are traveling at the opposite direction, they will bounce when they meet. You can try this at home by dropping a bouncing ball on the floor. As it hits the floor, it bounces back up into the air with the same momentum as before. When there is a collision between multiple objects and the final kinetic energy is different from the initial kinetic energy, it is said to be an inelastic collision. In these situations, the original kinetic energy is sometimes lost in the form of heat or sound, both of which are the results of vibrations of atoms at the point of collisions. Though kinetic energy is not conserved in these collisions, momentum is still conserved, and therefore the equations for momentum can be used to determine the motion of the various components of the collision.
perfectly inelastic collision. The objects stick together and travel in the same direction. A perfectly inelastic collision is when all the kinetic energy is lost, being transformed to some other kind of energy like deformation and heat. An example here is throwing soft putty at a wall so it sticks. Here all the kinetic energy was lost in the collision.